So the first speaker is John Micken from Biotech's Future. You will see their project at the very entrance. And John is material scientist at Adidas Innovation, and he will first talk about the project that they are exhibiting, and particularly, John, you are introducing some researches on new biomaterials. So what's the attitude of the industry towards biomaterials? So what's the problem that these materials that are bio-based had the difficulties in entering the market for real?
Yeah, I think definitely Adidas and other industry players see bio-based materials as particularly interesting for reducing the carbon footprint of products. There's a number of materials that are already at scale that can be brought into products. There's some challenges around how you account for biogenic carbon in materials that I think need to be overcome before they can really kind of be realized in products. But yeah, I think there's a lot of opportunities there. We've been looking at them in the textile industry in particular. So yeah, happy to talk that through a little bit more, and yeah, you can see what we've been working on.
Okay, so if you want to show something.
Yeah, so I just wanted to start with probably something quite familiar to any designers in the crowd. I'm not a designer, I'm a scientist, but I always think this is quite interesting from an innovation point of view. And just thinking about how an innovative material can be judged, right? We look at viability in terms of can we deliver it at a cost which makes sense for creating a profit in a business. Feasibility, you know, what's its availability in the market? Can you purchase it in a place where you make your products, and is it at scale at this point? Can you produce the volumes that you need? And then by far the most important one is this product desirable? Does it solve a problem that a consumer has? Is it beautiful to look at? All those different things. This framework's a really good, easy way of judging products, but I wanted them to apply this framework to sustainable materials over the last kind of, let's say, decades, and just think about, particularly in the textile industry, how have sustainable materials developed, and what are the challenges, and how can we maybe overcome them in the future. So to introduce another framework, this is the Gartner Hype Cycle, which I always think is really interesting. And it talks about how when a product or a material or something like that is launched, how you get this initial big hype and everyone talks about it and it's really exciting. And then sometimes you get the disappointment afterwards. But hopefully in time you get this plateau at the end of where we actually start to make some progress. And I think this has been really clearly happening with sustainable materials over time, sustainable products. You've got this really clear trigger of, we have a big climate challenge, we need to decarbonize, we need to increase the circularity of our products. That's the trigger for the innovation. And particularly in the textile industry, that initial hype was met with capsule collections, you know, people really excited to buy a sustainable material. But they were always in quite small numbers. They were quite expensive. They had high desirability because not everyone could have them, right? And it was very exciting. But in terms of the viability, they were expensive. In terms of the feasibility, we couldn't produce too many of them. And I think over time, that kind of hype naturally waned. And we got into a point of a bit of disillusion, actually, as consumers. You know, I'm a consumer, where that hype died down, and industry really needed to bring something into the market which was a lot more feasible and more viable. You know, so you got the rise of materials that were more like a drop-in solution. Thinking of things like recycled polyester, which has been huge in the sports industry, something that we can produce at scale, does have an impact on a carbon footprint, but also is quite boring. You can't see the difference and the improvement of that material. It just looks the same as any other polyester. And also there's many challenges, and rightfully so challenging, about could that polyester be better used and not diverted out of, for example, the bottle industry. So it's led to some disillusionment and a lack of trust of the consumer in the sustainability industry. What I'm hoping that we're getting to, and I sense this in the industry, is a period of enlightenment. And I think what we're starting to realize, definitely for circularity, is gone are the times of a brand such as Adidas, running their own circularity program on their own. It just doesn't work. We need to work together. We need to work with lots of different industries that are required to bring circularity to market in order to actually create this circular supply chain that actually works. What we've also realized is, and I think bio-based materials, this is why I'm particularly interested in them, is that there are materials out there that can better perform and outperform fossil-based materials, do something that they've never been able to solve problems that we haven't been able to do before. And I think there's a real opportunity, there's so much research going into these materials that we can produce materials with better properties that can outperform fossil-based materials in the end. And that's where I think we can get to a combination of desirability, feasibility, and viability that will actually allow these bio-based materials to hit market. And we get into that kind of productive kind of time. But we're not 100% there yet. Do you want to ask a question? Of course. But we do have programs, and I'm here representing Biotech Future, which is a German-funded innovation space, where we are trying to search for these materials to further research. And I think that's really, really important in order to take the next step in this journey and to get into this kind of phase.
Okay, thank you very much. Super interesting, and also it gives a very good connection to Fabio Bolzoni from Evonik. Because Evonik is, it's a huge company doing a lot of things, but particularly you are here as, and it's also your area of business, working in the area of additives for polyurethane.
Yes.
And basically functional additives to make polyurethane foam do something. So making it more sustainable, more technologically advanced, so functionalizing the material in different ways. So can you please tell us how these additives can help in the material performance?
In the stand, you can see the edge of polyurethane. This is the association that promote the use of polyurethane foam in especially interiors material. And Evonik is a chemical company which provide to the industry of polyurethane foam special additives to give special properties of the foam. You can yourself later touch how different can a polyurethane foam be. It can be soft, it can be slow recovery, it can be sustained. For example, you are seated on polyurethane foam, which is quite strong and can sustain your weight. Evonik is a German chemical company that helps the polyurethane foam industry to reach such performance properties. A foam can be antistatic, can be slow recovery, can be breathable, can be hydrophobic, can be hydrophilic. Many properties which are provided with our additives.
Okay, great. We had a bunch of kids this morning experiencing all the different texture and
exactly.
properties of the materials you had on display, and they had really great fun. And then in the second questions, I will ask you a little bit more about how these properties can also add sustainability.
Yes.
Just to, okay. So we have now Stefano Claudio Bison. Is a professor that has worked within the project Shape the Light. We have this project exhibited here through the artworks of 3 students. Shape the Light is a European project, and within this project there was what was called the Performance Lab, which was basically a workshop where students were guided by, of course, teachers in lighting designs, and they eventually developed 10 different concepts of art applied to light. And in the end, we selected just 3 of them, but not because they were all very valuable, but the 3 were the easiest, let's say, to prototype. And you can see the 3 of them in the 3 corners. So I would like to ask Stefano to
Introduce
tell
the
us.
school?
Yes,
Okay.
to tell us about the process. How
Okay.
was
Yeah,
this?
so first of all, thank you, and thanks to Luce in Veneto, that is the partner that gave us the opportunity to work and to be here today. So we started this workshop in September, having more or less 60 students. We are industrial design school. So where is this? Sorry. So yes, I'm representing Scuola Italiana Design. So it's a design school based in Padova. So we are the very first design school in Veneto, that is our region where we come from. We started in the 1991, and we believe in an approach that is more related to do. So we strongly believe that the best way to become a designer is to, let me say, put your hands on. So that is what we do. So we are a part of a scientific and technological park in Padova. Our course is 3 years of course in product and communication and UI and UX design. And during these more than 30 years, we have been there were more than 1,000 graduated students. One is here and is me. And right now I'm a professor of the school. So, well, this is again our approach. But if I have to speak about this project, was a little bit weird for us because when a designer receives a brief, the designer needs to have some issue and to try to solve some problems. In this case, the request was to give a shape to the light, and it was more an approach, an artistic approach. So what I've asked to the guys, I was the professor in charge for this student, was to try to figure out what they have inside, what triggers them, and what was the problems they want to highlight for this project. And that's why you can find some the three projects that we are looking today are very different. So one here was, oh yeah, sorry. Yeah. So the first one that is there is more related to the times that we are living. So it's like hopes and dreams. It's more related to what we would like that life will give us. So we took inspiration by, of course, the materials, of course, and also in this case, we were inspired by the Chinese lanterns. So this was this installation were thinking to be made with PLA, based. Well, maybe you know better than me, of course. Yes. This material, and at the end was more, something to the Chinese lantern is hoping for the incoming year. So it's like to let's fly away the bad things and try to having a hoping to the incoming year. And this one was try to breathe, that is here. It was like something to try to highlight what's the problem of the plastic of our oceans or our seas. So it was thinking to try to having the experience to see the light from a sea full of plastic. That was at the beginning the idea. And the last one was more related to lighting effects, lighting games, using this material that is a super reflective metal. and this was more related to a light game. So this was more or less what we've done in September, and that's it.
Yeah, and basically this one was a very simple artwork and made with totally recyclable materials, and also, yeah, the other one was supposed to be bio-based, but still, at the end, the prototype was made in paper, which is anyway a super sustainable material, and the third one would give, again, the impression of floating into plastic in the sea by using real plastic bottles for the prototype. Thank you very much for introducing these projects. I of course invite you to go and see them. Standex engraving. We will later dig a little bit more into the design, sustainability, etc. But first, I would like to ask you what did you bring here, and what's special, let's say, in the type of technology that you have developed?
Thank you. So first of all, who are we? We are company delivering surface finish for injection molds. So we work on the molds for injection molding to then deliver services to the companies that produce actually parts and bring to their molds the correct surface finish. What is the value? So so we are present worldwide, bringing the solutions, of course, next to the customer, and bringing those with very different technologies that are surface finishing. But let me highlight what's really in here, that's ours in here, and what's are we bringing new, that is actually texturing. We, as our really big solution that we bring to the customer is aesthetic textures to really highlight the product value, to bring to the product the real aim, the real soul that the producer wants to give it. So the brand to highlight the value of the product itself. And with that, from our perspective, I'm from the R&D. Now we are trying to bring also functionality to the surface. So that's what we do. Bringing functionality to the surface means to actually get, and I want to then to get there and touch the surfaces and see what's in here, to get new value to the product. And the value is getting, for example, a new surface finish that is getting a different perception of the part, and by that, for example, let me bring this. So a different surface finish will bring you the possibility to avoid processes, over-processing on the plastic part, cutting costs, and bringing the same solution as before. So to bring that, we are focusing on 4 different functions. There are optics, that is playing with light. I really like what you presented, because it really resonates to what we are doing with optical applications. By modifying the surface of your part, we can reshape, redirect, or trap the light onto the surface, giving new functionalities directly on the plastic part. Haptic, what does haptic mean? Haptic is actually changing how you perceive by touching the surface, how you perceive the surface with your finger. Wettability is how the surface is reacting really to liquids that spread over it. And adhesion is having a surface that is able to really slip over it. To really get our soul, what I was mentioning before, so the aesthetic of the brand recognition, the value perceived by looking to the part, with the functionality, so what you can actually touch and feel from the surface, needs a journey that we need to do with our customer that is full of milestones that are really brought into the reality, into numbers, through the characterizations that we can run on our research and development team. And the capabilities are spread around the world. So in a nutshell, really, that's what new we can really show here. That is how aesthetical textures and functionalities can bring together, can be brought together by us with a journey that we can do with you to bring these functionalities on the surface. I really like the presentation about TPUs and how the surface finished and the material can change how you perceive the surface. Yes, it's the surface, and by working onto the surface, you can again work and tilt and optimize what is your perception out of the surface.
Okay, thank you very much. We will then delve a little bit more into the different types, okay, of performance that you can get. Okay, now we have a general overview of what the 4 different projects that are exhibited here. I would like to make let's say a cross question that's more or less the same for everyone. And the first is for you, John. Can you please, concerning when you develop these new families of materials, how the relationship with the consumer, how design can help enhancing this type of, let's say, connection between these new materials, because as you were mentioning before, everyone is asking for sustainable solution. Anyone is buying it. No one is buying it, like for real. They love to have it in theory, but then when it comes to practical terms, oh, this is not, especially for performance good. We are talking about performance goods. Oh, this is not performing enough, etc. So, what's your perception about that?
Yeah, so I guess we would call this the say versus do gap, right, in industry. And it's a common thing, and I believe that this arises because when a consumer gets to buying a product, what they're trying to understand is, does this product help me to solve my problem? And can I stomach the cost of that product? And it's the value that's created versus the value and hard-earned hours I've had to work for this money in order to pay for it. And that's why I think in sustainability for too long we've asked consumers to bear the price of a sustainable material. You know, why should they pay more for a product that sometimes performs worse than the current one? And so, in my opinion, in order to overcome that say versus do gap, we need to stop trying to sell people a sustainable product and sell them a better product. And to do that, we need designers who understand, you know, what the problems that people are facing and how do we design a better product. You know, starting with a material is never going to work. We talked about this before. Yeah, just starting with a material and trying to shove it down someone's throat isn't going to work. We need to understand their problems, create better products, and then they will buy them. And if it's sustainable, that's brilliant. But that needs to be done by brands and materials companies in the background. And I think that's starting to happen. I think we've gone through this painful process of needing to learn that it doesn't work. And hopefully now we're getting into that more enlightened state of, okay, we can actually solve this problem. But unfortunately, it's taken a little bit too long, and we need to work a little bit faster.
Have you anything to show us?
Yeah, and part of that, as I was saying before, is we need these research projects to find these materials and to understand how we can apply them. So there's me catching a shoe. It's actually in the interview for Adidas. Can you catch a shoe that's thrown across the room to you? But this is our... No, I caught it. Of course, I grew up playing cricket in the UK. You know, of course, I caught that ball. But yeah, we have this innovation space. There's 20 projects, at least 100 different partners all across Germany. They let me in as a British person just by chance, I think. And yeah, what we're trying to do is we're trying to research these innovative materials across lots of different applications and really understand what are they good for, in the hopes that when they're needed by a designer to solve a problem, we already have them kind of ready to go. But we're always trying to produce materials that are better, are more desirable, but in a way that can be scaled and hopefully will be viable one day. Some of the projects that we're presenting today in the exhibition probably fall more on the desirable side and less on the viable and feasible side, but some of the other projects are a lot closer to scale. And I think these ones will get there in the end. It's just going to take a bit of time. So I have a quick video to show what we've been doing. And now is the moment of truth. Does it play?
Did you know 91% of the plastics used in our textiles are petroleum-based? It's time for a change. In Biotech's future, we aim to transform the textile value chain from petroleum-based to bio-based. Nature is our inspiration to create bio-based materials, colors, and finishes. From fungal and algal biomass to the molecular level of the gold beater's skin, we've validated innovative processes in different production phases and use cases while developing recycling solutions for our materials. But no matter how far we get, we can't do it alone. Society needs to be on board to drive this transformation. Come join us, learn more, and be a part of this change.
So the first material I'd like to talk about is this jacket produced by the Vint Design Lab in Berlin. This jacket was produced, and you'll see it in the exhibition just over there, from the stomach of a gold beater skin, so the stomach lining of a cow. But it's just the first exploration into collagen as a materials resource. And what's interesting about collagen is in the human body, there's 28 different types. It does so many different jobs. It's so versatile. And so the follow-up project to this, we proved that this material could be used as a lightweight waterproof membrane. But the follow-up project is understanding and exploring of how we can work with collagen to perform lots of different tasks in materials and really understand, okay, how do we edit this material to produce a stretchy material or to produce a material that can resist water, or many different jobs that we might have in society. So just showing how actually the performance and using versatility of a material can be really important. So that's the first one. The second project that I'll talk about is a piece of footwear produced from algae. This was a project that I led within the innovation space. And really what we tried to set out to do is understand, can we produce a material that doesn't compete with arable land that can otherwise be used for farmland. One of the downsides of bio-based materials is often they're produced from crops, and that can interfere with production of food. As we move through time, land will more than likely, unfortunately, be harder to come by because of flooding, and therefore this material we investigated to understand, can we produce the algae in a photobioreactor, so something that can be done on wasteland. The material that we produced is a polyamide, 6.9, so not exactly the same as that you find usually a polyamide 6 or 6.6. And what we found was that its water uptake was much lower than a usual nylon. We also produced a material, a yarn, that was stronger and more lightweight. So being able to produce more of a standard kind of material, something that isn't really cool and exciting like the chitosan, but still with these performance benefits. And then finally, we have this chitosan yarn, which is really interesting because it's used in the medical industry for things like socks for people with diabetes or for wound dressings. And chitosan absorbs water really, really readily. It also is antimicrobial, so it can stop the formation of bacteria, which is why it's great in the medical industry. And what we used it for here, and this is a very close-up image of some leggings, you can see them over in the exhibition. But we mixed it at about 12% into a blend of wool and polyamide, And we're actually able to prove that it uptook a lot more water, so it absorbed sweat and kept you comfortable while exercising, but also reduced the buildup of odor, something that we know from in the sports industry is one of the main reasons why we change our sports equipment, because it smells of sweat. It's unavoidable, you know, that's what people do when they exercise. So these are just some examples of the materials that we've been working on. But what we really wanted to understand is how do consumers view these materials? And in the algae project, we actually went, sorry, this is in German, we went and we had a space in Berlin in our flagship store at Adidas and sat down with people and asked them about these materials and actually got them to co-design with algae and tell us about what they really would think of a shoe made of algae. And one of the things that surprised us here was people weren't really looking for something that reminded them of algae. They didn't want something that was green. They didn't want something that was slimy. When it's a sports product, they look to Adidas to provide a strong, durable, lightweight, kind of clean product. Algae wasn't what they were looking for. So I think when we started this project off 5 years ago, we were like, algae's really cool, let's make something out of algae. But actually where we got to was, in order to communicate this and design with it, we should lean more into the kind of high-tech side. So we came up with this idea of a material that was born from light, linking together what we wanted to kind of create with the consumer, a lightweight, powerful product, and the way that the algae was cultivated using the light. And really kind of what I hope to deliver with this presentation is scientists like myself can do all this work. We can prepare the world to have these materials that hopefully one day are desirable, feasible, and viable. But without designers to really understand the consumer's problem, the people's problem, and actually apply these products in a creative manner, we're always going to have that say versus do gap. We're never going to overcome it. So really this is just an open invitation for designers to look at these materials and use them, but use them in a creative manner. So thank you to the funding body, the German funding body, one, for letting a Britain, and two, for providing the money for all of this amazing work to happen. That's the German Ministry of Education and Research. And yeah, thank you for inviting me and for the discussion.
Thanks to you for coming and showing us this really amazing project, very, very interesting and very looking ahead, I would say. That was very interesting, the idea that consumers wouldn't expect to have real algae shoes, but rather maybe they were thinking of algae as seaweed.
That's usually the association. Yeah, and people don't want a sustainable shoe. They want a shoe that allows them to run quickly. Yes. And that's what they look to buy from a company like Adidas. So that's what we should sell them, and it just so happens to be sustainable, in my opinion.
Okay, now that's, again, this connects a lot with the next question, yes, to Fabio. And it is how how functionalization of materials can also help in really achieving better sustainable performance. Yes. Meaning that, okay, in theory, we've been discussing in the previous question a lot about the difference between being sustainable in theory and then making it something that's real in the industry, that's viable, that's also price-wise viable. So how the additives, meaning changing the material, can help improving some processes?
Yes, as described before, I'm representing Evonik as a chemical company working to provide to polyurethane foam any kind of performance. And of course, Evonik is also helping the industry of polyurethane foam to become more and more sustainable. How can this happen? As described before, also polyurethane, now the majority of polyurethane foam are produced from fossil material. So he spoke about 91% for textile materials. When you think about mattresses, furniture, you can also be on this level of super use of fossil material. This is, of course, a contribution of the CO2, global warming, and we have to understand that the fossil material more and more will not be available any longer. So it's a trend to think to use more and more materials that are coming from renewable sources. Evonik, as a specialist of additives, allows the industry of polyurethane foam to be able to use more and more raw materials coming from renewable sources. Of course, as described before, these renewable sources should not compete with the food chain. We should not create a problem in area of the world where food is an issue, so never compete against the food chain. But we can use renewable sources materials in a way that our additives support this transition. Try to produce more and more polyurethane foam where the raw materials are not coming from the crude oil, but coming from natural sources. And our additives helps this transition. But you can also help the environmental, for example, if you reduce the cost and the pollution coming from the transport. Imagine the mattresses. In the past, the mattresses were not possible to be transported squeezed in a foam. Now, if you can buy a mattresses and receive the mattresses in a box. How can this be possible? Because you can really squeeze the PU foam, you remove the air, you pack under vacuum in a box, you use one truck to transport 10 times mattresses, and you can understand the saving for the pollution. This is possible because Evonik helped the polyurethane foam producer to be able to allow the foam to completely come back to the original foam. So you can also be proactively reducing the pollution using these tricks. Last but not least, we have to think about the end of life. And until this aveniristic solution are coming, we have also to think how to recycle the production which is still fossil. Scientists are thinking about the future, but in this transition we have to think how to find a solution to the old mattresses, to the old sofa, and Evonik invented a process that allowed the polyurethane foam to be chemically recycled. An old mattresses is bring in a special plant where the textile, the metal spring, and the foam are separated. Then the polyurethane foam enter into a chemical process where you can achieve again raw material to be bring back to the production of new mattresses. This is called chemical recycling. So when you will later go to touch the polyurethane foam, think that there are chemical companies which are investing not only to provide more and more performance materials, but also think how to produce this foam using less and less fossil raw materials, and thinks how to avoid that at the end of the life of these items, furniture, mattresses, you can find a way not to burn it, not to waste it, but to find the possibility to reuse these end-of-life items.
Thank you, thank you. But it is also super important that designers know that
Yes.
these things exist.
Yes.
Because I had a conversation before with some designers, and they say designers within a company, so not independent. So people that make decision about how things are done in the end. And they didn't even know that there was recycled foam that they could use inside their seats.
Yes, of course.
Okay? Because they rely to their current suppliers. Current suppliers, of course, they try to sell new stuff, of course, because that they have higher margin and everything. So yeah, it's super important, the role of design. And so I'm coming to you. So we think, okay, we have this, I guess that design was very important in the project that you carried on. And so how is design changing with the introduction of new technologies when it comes to light design within the green and digital transition?
Simple question.
Yes, yes. The
Very simple.
Give us, yes, give
Yeah.
us an overview as
Yeah.
a teacher in design
I,
of.
I don't think I have a properly answer. As a designer, we have a lot of questions inside. I don't know if I have the right answer. But what I can say is that, of course, these new material are giving us more and more and more inspiring solution. And what I believe is that these times are maybe the best one where we are not reaching out the perfection of the surfaces and of the material, but where imperfections maybe are having a big value and became something beauty as you know the perfection 15, 20 years ago. So speaking about this green revolution, what I believe is that maybe we have to zoom out from our use habits. We are used to think about a product to a long-lasting product, but maybe we have to change our perspective and maybe thinking about some products that has their own lives. By changing the time, of course, living on with that product, also the imperfection, maybe the material can change, and that could be something interesting to to become a value. So thinking about the lighting design, what I really hope that is that in the future maybe we will have some lamp that will change the shape because of the material will change, maybe with the temperature, maybe because of the changing of the passing of the time. So I don't know, it's something that I would like to give really a life to the products. And you also talk about technology and green. It was digital and green. Well, that's another good point. And of course, thinking about light and digital, what I think is that also light as a therapeutical, yeah, thank you, value. So I think that technology can give this new value, this new role to the lighting design. So maybe having some, there are some companies that are doing lamp that are trying to give the sunlight inside the room. Oh, yes. Yeah, so yeah, also IKEA, that is, everyone knows, is trying to giving you the possibility to change the color of the light, changing with your mood. And it's something that is very interesting to investigate. So how the technology should change the light, the environmental light, but from a therapeutical point of view. Well, again, I have a lot of questions inside, not an answer maybe, but yeah, that's my point of view.
Actually, that's exactly what design is about, questions.
Yeah, right.
So not answers.
Yeah.
Thank you very much for this perspective on light design, of which I don't know absolutely anything. So it's a very interesting field of design, because it's dynamic. I mean, it's not just the shape; it's how also the light interacts with the environment.
Yeah, that's the point. That's the point. So, well, I'm in charge right now. My role as a designer right now is designing for a company in Italy that makes high-end speakers. So I'm talking about another another field, but we are still talking about life, about emotion, about life that change every day, day per day. So as the music, also the light has a big and really central role in our lives. So sometimes you enter inside a space that is really with bad lighting, and also your mood, your perspective. Well, maybe you had a bad day, and that feeling enhance and become bigger. So that's why I think that also light has to become something to we have to give a new value for lighting, not just the beauty of a lamp, but of course also something that can help you to face day by day this life.
Okay, thank you. Let's go to something tangible but sensorial at the same time. I would like Leonardo to go through all the different things that can be done in terms of, again, maybe changing also the interface with objects through just
Yeah,
working on the textures.
Yeah, actually, speaking about light and as a dynamic thing, and how we can shape light, and for therapeutical purposes, that's something that actually I didn't have in mind because I had other application in mind. But yes, now I'm gonna get through some, as already mentioned, some different technologies, some different functionalities we can bring, and I really want to show that. It's okay? Okay, yeah. To you as designer, to really give you the first little light, speaking about light, to then make your question in your head and then understand how you can use it, where. So let me touch it real quick, maybe one by one, but really to open up new possibilities for your designs. So now we are looking actually to light management. Those are microstructures. This is the same light we are getting behind the screen. This plastic part, it's there. You can go there with your phone and go with your light passing behind the plaque, and you will see different shapes. This is a line. This is kind of banded. We can bend it as much as you want. We can diffuse it circularly, more or less. We can do a square. You can go there. It's much better square than this one that is short there, if you go, or triangular shape. There are many applications, like to redirect light. You can put your LEDs where you want that, where you can get heat out very easily. Those are technical reasons. And then you have the light where you want. You can redirect the light really where you want. And this is done actually by working on the surface. Staying on optical applications, this is anti-glare. You know when you are into your car and you are looking to your screen, and what's happening under the sunlight is that you are not seeing anything below. So those textures, and again it's there, are made and designed to reduce any glare from the surface. That's why it's called anti-glare, and to diffuse the light, but they are designed to letting you see what's behind, so letting you see the screen and the content. This is, again, let me stress that, made on the tool, and then as you inject the part, you are going to directly have the finish and the function on your plastic part. So there is no need of coatings or additional films, and this is really good for cost first, but sustainability. So the recycling of those parts, it's just that material. It's not changing. We are putting there the function because we are changing the surface morphology. And again, another optical application, diffusion. I have those lights that are pointing into my eyes right now. They are not soft, but with those kind of textures, we can really get soft light. We have different solutions, but let me really get to the function. LED hiding. Now there are many different light applications, and you were mentioning some of those. with LEDs because they are so easy to put everywhere. But really, they need to have the soft light, and this is really, again, an application to diffuse light very properly. And we can, sorry, go back a little bit. We can mix this one with the first ones to diffuse and redirect. So you can really play with those functions. The structures are really small, so we have the chance to really play with the function. This is again the last optical application. This is black. So again, let's go into the car. You're driving under the sunlight, and your dashboard is reflecting up to the shield, right? What if we trap all the light that is getting on the dashboard? It's not reflecting anymore. So that's, for example, an application. But again, this is just to show and to show the function. What's really in here. Now the lights meets the aesthetical. This is the most aesthetical function I'm showing. It is a function because here we are actually splitting all the colors that are in the white light, and we have this colorful iridescence that is going to change by changing the way you're seeing the part, giving a colorful application. Again, all those parts are just behind you there, so you can go there, touch there, and look at those. Speaking about touching, this is Velvet. We got inspiration from Velvet, so from the tissue itself, and the objective was to bring the same sensation you have by touching the tissue on a plastic part directly without any other process applied. And that's what we brought into the Velvet texture. Again, it's there where we can apply that, why it's so interesting. For example, speaking even today with people that were passing by, they were like, oh, there are some plastic parts that are on my seat that is made out of velvet, of a tissue, and I want it to, feel more or less the same, to have the same perception. And yeah, why not? That's for sure something that really meets what you're expecting. Another kind of application that is always bringing this perception of the surface is silk. In this case, we were pointing at silk fabric. The feeling is really different from velvet ones, but the morphology also is totally different. But really, the application and the way you can play with that, it's really, really the same. It's really up to you. Now we got to how surfaces can interact with liquids. This probably the most crazy function you can see there. This is standard polypropylene. You have it all around your home, and by applying our texture, you can actually make it hydrophobic directly without any coating that's usually made. This is bringing also self-cleaning functionality. The inspiration is the lotus leaf. The lotus leaf, it's there, it's in nature, and always us as scientists take inspiration from the nature. And sorry, it didn't go. Okay, so this is how it moves, but you can get there and play yourself with water and with the surface. And by having this behavior, you can actually trigger self-cleaning. So you see here, those are actually the drops that dropping on the surface. They're gonna bounce, and each place they bounce, they are gonna bring the dirt down. They're gonna bring the dirt away. This is an effect that is actually triggered from super hydrophobicity, and by using this function, you can easily get a surface that is both dry and clean. Oh, it's working, so you can even see those. Sorry. So you can see how water, this is tap water, can see. Let me add one thing, since the video is really working well. This is the standard material without the texture. So this is how it behaves. And this is how it behaves with the surface finish we are proposing and we have here. Okay, sorry. Last thing, really last message is those functions are really now brought together with aesthetical value, and that's why we are here with you, speaking with you, and we can mix whatever beauty you had in mind, and we have there, and you see the manta there, with the functionalities of the texture that I showed. Thank you.
Oh, does this? Okay, now it works. Thank you very much, Leonardo. It was super interesting. Of course, the materials are there to be touched. I mean, explaining them doesn't really make sense, but I think it's important to have an overview just to understand how they work. And thank you everyone to be here tonight, and for the different perspectives. So we had something about bio-based, something from the very, very heavy industry. So that how, I mean, the chemicals can also help basically doing things that we need, because of course these types of material are still very much needed in a better way. And then also I'm very happy that design students can also embrace some sustainability values and change, let's say, the mind of how the future manufacturing can be. And also thank you for Standex Engraving Moltech for the very broad array of possibilities that you can give to designers to do things in a simple way, in a way, no? Because you don't need any overcoatings. It's something that gets out of the mold in one step only. So that's the most.
It's the net shape property of the process. Yes, it's one step. It's the same step you have to do to form your part, and by tweaking the process to have a correct one to really get the functionality out of this process. But it's the same process. Okay. Optimized, but it's the same process.
Great. Thanks a lot, and thank you for listening to this conversation. And I invite you to see all the materials that are over there inside. Thank you.